So I want to go over number 4 and number 6 with you and kind of give you a couple little things to think about before you take your test on Tuesday. And the reason I picked number 4 is because it is a short answer one. These should only take you about, like I said, 10 minutes to do. And you're going to have the whole free response section to do. So pacing might be something that you need to think about. So question 1 through 3 are going to be the long form or the longer parts of the question. And then 4 through 7 are going to be the shorter ones. So for question 4A, this is Q is equal to MC delta T. Again, should you have 3 sig figs there versus 2 sig figs? I know I've always taught you that the specific heat or any kind of constant would not be something you look at for sig figs. So that is why you would have like a plus or minus 1, meaning if you wrote down 190 joules here, you're probably going to be pretty safe. So 2 to 3 sig figs is going to probably get you to the correct answer most of the time. Letter B, I'll be honest with you, I did make the fatal mistake here. I did not put over 4 moles. Always look at the balanced chemical equation. I had a 4 in front of the Fe that gives you that amount of energy out. So that is why I get 4 moles per that many kilojoules. So I could then find my number of moles. And then it's always in your best interest, whatever the periodic table says for your molar mass, use that number and keep it all in your calculator and round it at the end. Again, they're probably going to have a range of numbers that they're looking at in terms of correct answers. So don't ever think that, you know, if you round it somewhere in the middle, that it's going to be the end of the world, because it probably won't be. So part C, you should have said greater than. That is because if you're using more Fe, you would get more heat. Therefore, you would have a higher temperature. For this reaction, realize that you were reacting it with oxygen. Okay, and oxygen will always be in excess, meaning you're doing these experiments out in the open in most cases. So you're going to have as much oxygen as you possibly could need. So iron would be your limiting. The sand is just to kind of have the experiment take place. I don't believe the sand has anything to do with it. So the iron, if I use more of the reactants, I will get more heat on the outside, on the other side, and then therefore a higher temperature. Yes, Kevin. The question was, do you need to show units in work? I don't think so, but I don't think it's a bad idea to do. What's your second question? Okay.
So I guess like this value decreases and like the increase in mass is negligible. So therefore like the storage heat has to increase.
Are you still saying that the temperature would be bigger?
Yeah.
But your rationale is what again?
So
because you have more sand in there? No, there's more iron. But why do you say it's a decrease?
Because I assume like so it's like I assume like the average, like specifically not like the average.
Okay.
So then if you add more iron, I assume iron has a lower heat capacity.
Okay.
So then the average heat capacity of the new mixture with the added iron is lower. And experiment one.
All right, me and Kevin are gonna have a little discussion later. I don't know what the heck you're talking about. Why would it be lower? You have more iron. Yes, it is mass dependent. It's joules per gram degree Celsius. You're thinking of heat capacity. You're not thinking of specific heat capacity. Is that what you're getting confused on?
My thought process is like the specific heat capacity would change.
No, specific heat capacity can't change. All right, me and you are gonna have a little discussion. I do not know what you're trying to say. All right, so go to number 6. Go to number 6, please. Go to number 6. So reason I wanted you to skip over number 5 was, again, that's an electrochem problem. You could take a look at it. It's not a bad problem. I'm just saying we just talked about that. So I'd rather talk about number 6. So I have calcium sulfate versus lead 2 sulfate. Realize that the calcium sulfate versus the lead sulfate, what you need to say is they are both ionics. They are both ionics. So that is going to be key in understanding why it doesn't conduct when it's in the solid form. That may be all you need to put down, is that they are both ionics. But I put in some additional stuff like ionics have lattice structure, the ions are not free to move, there's no free electrons, so therefore you don't have the conduction that you would have if you did have free electrons moving around. So, but I'm, you know, since this is part A of a question, it might just be as simple as they're both ionic compounds. Okay, so just keep that in mind. Part B is getting at the fact that they put both of these solids into water and they got them to dissolve. And they found that calcium sulfate has a higher conductivity than the lead 2 sulfate. Well, that should tell you that the calcium sulfate is more soluble. So more of it will dissolve. So you're going to get more conduction, meaning you have higher conductivity. So it'd be a brighter light than, say, the lead 2 sulfate would be. That is because you have more ions in solution if it is more soluble. So you would get more conduction. I never spent any time in class on something called KSP, which is called solubility product constant. It was in chapter 15. It was the last part of that lecture series. And I said, kind of skip it. I thought I would have time to come back to it, but I didn't. Sometimes KSP is on there. This question is not specifically asking about KSP, but I wrote both of the numbers down for both of them. KSP has to do with how, when these ionic solids are in solution, most of the time they stay together when they make the precipitate, but when the precipitate forms, you also have a reversal of an equilibrium equation. So you have some calcium ions in there and some sulfate ions dissolved. The KSP, the bigger the value, the more it breaks up. So think of it just like a Ka or a Kb or any other K that I've taught you. So if they give you a table of KSPs and say which one is more soluble, you just got to look for the bigger number. Okay, so that's why I put it on my answer key. It's not necessary for this answer. I'm just trying to cover all of my bases for you to take the test. The other reason I picked this one was because it had a drawing on it. They like to do drawings, and because you guys are taking the paper and pencil test, you need to be aware that you're probably going to have to draw something. Okay. For this drawing, what I would think they're looking for is that you would have the solid lead sulfate on the bottom. I don't know if you would have to have the same number of circles that they drew here, but I drew a couple extra ones because only 2 of the ions or only 1 of the lead sulfate broke up, compared to here where you were saying that you have 3 calcium sulfates that broke up. Somebody brought this up in the previous classes. You need to have equal amounts of pluses and minuses in there because this is a 1-to-1 relationship. If this happened to be copper 1 and sulfate, then you would see 2 coppers in there and 1 sulfate, like we talked about way first semester stuff. So please be sure that you are proportional to what is dissolving in there, okay? Could you get credit for 2 pluses and 2 minuses, meaning 2 of the leads broke up versus 3 of the calciums? They would probably give you credit for that. As long as it wasn't 3 of the pluses and 3 of the minuses, then therefore you couldn't, they would not give you credit for that. So just kind of keep that in mind. And then finally, letter D. This one is asking about the fact that a student tried to increase the solubility by adding H2SO4 to the beaker. SO4 is the common ion here. And so when you are looking at the solids like calcium sulfate, when they dissolve, They form the ions, however many ions that you have in there. So I'm adding more SO4 to this equilibrium. So that's going to shift it to the left. It's going to shift it to the left, which is going to be the calcium sulfate as the precipitate, as the solid form. So that is why you make more precipitate, because you are shifting it to the left. Somebody brought up in the previous classes, should I also talk about the fact that it is decreasing the solubility, meaning you're getting more solid forming rather than getting more of solid dissolving. You might need to add that as well. But because they're asking about explaining the observation of the additional precipitate, I think that's all you need to talk about. But again, this is my interpretation. I might be overthinking some of these things, but I want to make sure that you get some feedback on that. All right, so any questions on either 4 or 6? Uh-huh.
The actual solubility, say like in our drawing, 2 plus and 2 minuses wasn't solid.
Oh, down here?
Yeah.
Again, I think it would be best if you mimic whatever they give you. So I mimicked what they gave me here. So I had, essentially 4 columns here. So I kind of represented 4 columns here. I put an extra one there. And then I dissolved this one. I don't think they're going to spend the time counting each one of them, but I would mimic what they have here. It's always in your best interest to show kind of what they already did and then expand upon that, if that clarifies. All right, so your test is on Tuesday. Okay, your test is on Tuesday for chemistry. I will not see you until you take that test. Realize if you are not taking the AP test on Tuesday, you do need to check in with me on Zoom, or I will be marking you absent. So there are a few people that are not taking the AP Chem test, which is fine. But we are just going to check in for attendance and go from there. On Thursday, we are going to review for, we're going to spend some time talking about the final, and then we have the final the following Tuesday. And on Tuesday or Thursday, or maybe sooner, I will be publishing the list of people that don't need to take the final. I did drop your lowest test score and your lowest quiz score at this point, so you can check out your grade. That's your grade going into the final at this point. So I am going to let you guys go. If you have questions about the multiple choice section or anything else, I'd be happy to stay on Zoom and talk to you about any specific questions. Otherwise, get some sleep. Do not spend all of your time up late at night, okay? That's not going to work. You need to look at everything, but don't hyper focus on any one particular topic, and get some sleep, okay? Some of you don't sleep enough. All right, so again, good luck, everybody. I will see you on the other side of AP tests.
I have a question really quickly.
Sure, no problem.
For the final, what grade did you say was like the grade that you don't need to take the final anymore? Like,
you kind of need to be in the middle of an A or a B or a C.
So like a 95 or 85?
Somewhere, but you will see it. You could do the math yourself, because the final is only 10%. So yeah. I'm kind of doing it based off of, if you get a 50% on that final, would you keep your grade?
Okay.
So that's how I'm doing it.
Yeah.
All right. The rest of you hanging around, do you guys have questions for me? Bye. We have the standard people who are asking questions, so that's good. Okay, all right. Do you want to just stay as a group? Do you want to go into breakout rooms? What do you guys want to do? I think it'd be better if we just stay as a group, and then if you have a specific grading question or something about your grade, I'd be happy to put you in a breakout room. Does that make sense? Okay, all right. So, Shani, do you want to start?
Yeah, my question has to do with number 4 on the response we just did.
Okay,
The enthalpy is 1650 kilojoules per mole reaction. Why
right.
would you not multiply it by 2 because you have 2 moles of the product produced?
I would say it's because it is off of the fact that you are talking about in that balanced equation, you're trying to figure out the iron part of it. And so since you're trying to find the iron part of it, the iron is based off of the 4 moles makes that amount of energy.
Okay, so whatever the test gives us, like the delta H of the reaction, regardless of the coefficients, is it usually just that number, or would we have to multiply it?
It depends on how it's written in terms of what they're asking you to do, but because you're talking about reactants here, the iron part is the reactant, so that's going to be what's driving that equation.
Okay.
Okay. Rajvi?
I have a couple, so
Sure, that's fine.
okay. Well, my first big thing is like when I was looking at the old FRQs you put up, I was looking at the answer keys, and there were things where like in my answer I was like, this is endothermic, so you add like heat, you add reactant, and then it shifts right. And
Okay.
then their explanations, they just use like fancy words and things like that. Am I going to get docked for not using that terminology?
Can you be more specific, or can you give me an example of what the words that you're thinking are fancy?
I didn't write down that one specifically, but for something that was like just like more electrons means more like possibility for instantaneous dipoles or whatever, they wrote like greater polarizability of electron cloud.
Oh, I see what you're saying. Well, I will answer it this way. The answer keys that you see are what they call the generic answers. So when they actually grade the test, they then expand their answer key. So I would say the way you answered that question would be fully acceptable.
Okay, so then if I'm like explaining a topic instead of using like the specific, okay,
Right.
sweet.
Yeah.
That's great. And then yes, another one was like for entropy, instead of saying like aqueous solutions, I explained it as just like the molecules are like the ions are free to move around. They wrote a greater possible number of arrangements.
Okay. You could put it the way you put it, but again, entropy is what they call how many possible states could you organize the molecules. So they're called microstates. So how many different options do you have of rearranging those things? So I think that's why they're putting that answer that way.
Okay, I will remember that. And then the last one, this was like a specific topic thing. When we were talking about the van der Waals equation with like, or just like when a gas is at like a really high pressure, the ideal gas law doesn't work. I thought the pressure would be greater than you would get by ideal gas law, but is it the key said like the explanation was the other way around. Can you explain like how that works?
They said the pressure is less than?
Yeah. The way I feel like when I see questions like that, I'm at the point where I can just change my reasoning to match what they're looking for. But the way that I thought of it when you explained it is like because they'll like cluster together, like when they collide, they'll like make more of an impact, so that's more pressure. But I guess if there's like if they're clumped, then there's less individual things colliding or something. I wasn't sure what like the logic was supposed to be. But in the explanation, they literally just said higher pressure means more attraction or something like that.
More attraction. Yeah. I guess the thing with higher pressure is it could also mean less volume, lower volume. And if they were clumped together, then they don't have much room to go around. like you said, they're clumped together so you don't have as much hitting each other. So therefore you have less pressure that way. But yeah, that is where, like, if you looked at number 7 on this year's test, letter D, I have a problem with that one as well.
Yeah, I had a question like mark, and I was like, I'm sorry, I don't understand for that one too.
Yeah, I put, again, van der Waals equation, volume, you subtract away the gas particles in terms of moles and how big the molecule is. So therefore the volume would be smaller, would be my rationale.
Okay, and then I think for 7D specifically, it was talking about like condensing into a liquid or something, and that takes up less.
And so the liquid, yeah, would take up.
Okay, so do we just say like liquids take up less? But that doesn't make sense to say.
No, that doesn't.
Oh, that's frustrating. Okay.
Yes.
I'm at the point where if there's questions I don't know, I'll just change my logic to what they're looking for, because I feel like a lot of these questions, they're not like what will happen, they're like explain why this.
Right.
That's fine.
Okay.
Fine. Okay.
All right, Krish?
I think so.
I had a couple of questions regarding the multiple choice that we did back on Monday.
Okay.
I was like wondering, like, if it's possible to go over what's it? I think question 18, I believe.
Hold on a second. Let me give me a moment to get my AP classroom up. Okay.
Okay.
Yep. All right, Krish, can you see my screen?
Yes, I can see your screen.
Okay, so which questions do you have a question about?
I had a question on number 19 first.
Okay, what was your question on number 19?
I think I forgot how to do this question, I guess is my question. So
You didn't forget how to do it. I never taught you how to do it.
Oh, I see. Okay.
Okay, so this was the PES thing we were talking about last time. So it's called the photoelectron spectrum. So it has to do with bonding energies of the electron being held in by the proton. So element X on the left versus element Y on the right, you will see that element Y, its peak, one of its peaks is between 11 and 12. So that means those electrons require a lot more energy to take out of the atom. Versus element X, you have a peak between 5 and 6. So therefore, the reason the answer is Y is because that peak is further to the left. So that means it has a higher nuclear charge, meaning the proton has more power over those electrons. That is why it requires more energy.
Okay, so just to clarify, for a greater effective nuclear charge, then that means that you need to have more
Protons.
protons.
Yep.
So on the periodic table, as you go to the right, then that means that your effective nuclear charge should increase, right? Or is it the other way?
Yes, that's why when you go from left to right, the size gets smaller because the effective nuclear charge is increasing.
Okay. Um. Also, I was wondering if you'd could go over number 39, please, as well.
Okay, so this one is a KSP one. So one that I maybe just described to you, so maybe it'll make a little bit more sense now. It says you have 3 saturated solutions of X, Y, and Z are prepared at 25 degrees Celsius. Based on the information in the table above, which of the following lists the solutions in order of increasing Ag plus? So now when you look at those KSP values, which one has the highest number?
Y.
Okay, so that's the one that is going to dissolve more, be more saturated with Ag plus.
And the more solubility you have, the more concentration of Ag you have in this
Yes,
case.
it'll be more dissolvable.
Oh, okay.
Yep.
Okay, that makes sense.
Yep.
Let's see. There was. Yeah, number 27 as well. I was wondering if we could go over that as well.
Okay, so why high carbon steel more rigid than low carbon? So we have low carbon, less carbon there. So information about 2 types of steel, both of which are alloys, iron and carbon. Which of the following best to help explain why high carbon steel is more rigid than low carbon steel? So again, we didn't talk too much about alloys, but if you have a piece of iron and you start to incorporate carbon into it, it's called an alloy. And what it will do is change the properties of that iron. So because they are telling you the high carbon steel is hard and brittle, meaning you have a higher percentage of carbon in there, the answer of the additional carbon atoms within the alloy make it more difficult for the iron atoms to slide past each other. So remember, metals have metallic bonds in them. And so they have that valence C of electrons. They are delocalized. They do not belong to any one cation. So therefore, if I introduce something into the metal and make it an alloy, it will change its properties.
Okay, so then that means that the more carbon atoms you have, the more difficult, I guess. The more harder it is, I guess.
Right, and that's what they were showing you there, hard and brittle. So low carbon steel are malleable and ductile. So that's telling you that putting that more carbon in there is changing those properties.
Okay. All right. Also, would it be possible to go over question 44 as well, please?
Okay, so compound CCl4 is non-flammable, most commonly used in fire extinguishers. On the basis of periodic properties, which of the following compounds can most likely be used as fire-resistant chemicals? So what's your question on this one?
Why is it CBr4?
Okay, well, what does Br and Cl have in common?
They're both halogens.
So you see how they say on the basis of periodic properties. Periodic properties means it's in the same column on the periodic table. They're going to have similar properties.
Oh.
Okay.
Okay. Okay. Wow, that was a lot easier than I thought it would have been.
Correct. Right. So again, look at the carbon. So you want to look at the 2 answers that have carbon in them, right? And then CH4 versus CBr4, which one does it look more like? CCl4 is going to be more like CBr4.
Oh, okay.
Yep. So that's how you kind of eliminate some of the answers.
All right. I think that was all I had for now. I might have a couple more, so I'll just stick around.
Okay. All right. Isabella?
Oh yeah, I had a question for part D on the free response that we did today. Like
Which question?
yeah, number 6.
Number 6?
Yeah.
Hold on a second, let me grab it. I kind of put it in a different place. Okay, so part D, yeah. What was your question?
I was wondering, like, do you have to specifically mention like the common ion effect, or can you like say, since it's a strong acid, it'll completely disassociate into the H plus and SO4 ions, and then the SO4 will react with the Ca 2+ ions.
That's fine. I don't think you need to say common ion effect. No. No, I would think that you're just seeing the SO4 2-, and that's part of the CaSO4. So yeah, no, I don't think you need to see common ion effect.
Okay, thank you.
Uh-huh. Shani?
I had a question about implicit mole calculations. So on some of the FRQs I was looking at, it said you get the points for calculating moles if you did it like with gravimetric analysis, but then others it wanted the mole. Do you know if like implicit is widely accepted or not?
Can you be more specific on what you're asking now? Because I'm not
Yes.
sure if I know what you're asking.
Like for example, if you have a gas question,
Uh-huh.
they give you the grams, instead of calculating the moles and then plugging it into the ideal gas equation, you just change the ideal gas equation so you have grams over molar mass. So you're
Oh,
actually calculating, like you never have like the exact moles listed, but you account for it in it. Would you still get the mole point?
oh, I see what you're saying now. Yes.
Okay.
I think what they do when they do their answer keys like that is to try to give points
Mhm.
when they don't get the right answer. So
Okay.
if they find somewhere in the calculation that you see the moles have been calculated correctly, they give them a point. And
Okay.
then they didn't do PV equals nRT right, and so then they lose that point. So I do believe that if you put it into your, as long as you label everything, they will give you credit for that.
Okay, thank you.
Unless they're asking specifically for the moles.
Right.
Right, okay.
Okay, that was it. Thank you.
Okay, you're welcome. Isabella, did you still have a question?
Oh yeah, I had like a grading question.
Okay, all right, I'll put you into a breakout room then. So what's your question, my dear?
Okay, I noticed that in Infinite Campus it said like the AP Kinetics quiz, I think, was like missing.
Okay.
I think that what happened was like I forgot to like click the submit button. It's like I filled in all the work.
Oh, okay. So you want me to go back? I could go back and do that.
Yeah, okay. Okay,
Is
thank
that
you.
it?
Yeah.
Okay, awesome. I could do that. Have a good one.
Yeah, you too.
Did you have any more questions, sir?
Yes, I did. Going back to the multiple choice, if you don't mind, would it be possible to go over question 6, please?
Sure. Can you still see my screen?
Yes, I can. Yes.
Okay, can you see number 6 right now?
Mm-hmm.
Okay. So it is asking first ionization energy element is energy required to move an electron. Values for the first ionization for the third row elements are shown in the graph above. Okay, so I think there's a glitch. Hold on a second.
Yeah, sure. No problem.
Because the let's see if it'll populate. Okay, there are the answers. Okay, it wasn't populating the answers. Okay, so it's asking for which of the following reactions is exothermic. So do you see that Al is at a lower ionization energy than magnesium?
Yes.
Okay, so that means aluminum requires less energy to remove that electron than magnesium does. And this is only the first electron to come off.
Okay.
So therefore, when we're looking at the correct equation here, aluminum is going to release less energy when it becomes Al plus 1,
Okay.
okay? While magnesium is going to require more energy. So if you think of it this way, magnesium, its energy, so if you look at the correct answer, magnesium plus to magnesium gas, that's going to be a much higher number than aluminum going to aluminum plus.
So then how does that make it the answer then?
Because you have extra energy at the end, because the aluminum is not the same quantity as the magnesium was.
So in this case, it's asking which reaction is exothermic. So would all of the other three ones be endothermic then, and why?
Because chlorine is higher than magnesium, so that wouldn't work. Phosphorus is higher than magnesium, and sulfur is higher than magnesium.
So then, like, you know, in this case, if an element is higher than magnesium, then that means that it would require more energy to remove the electron.
Right.
So,
So write out the equations
okay.
and see if that makes more sense to you. Because again, aluminum going to aluminum plus 1 is going to require, you know, let's say it's 700. While magnesium plus to magnesium is going to be, let's say, 750. But the 750 is going to be a negative because you flipped it.
Oh, because you are. Wait,
Right.
so you are gaining an electron, which will release energy out.
Right.
So then, in this case, yeah. So in that case, you will still end up, like, you know, with around -50 as your delta H versus an
Right.
exothermic reaction.
Correct.
Oh, okay.
Yep.
All right. That makes sense. Also, would it be possible to go over this question 40? Yeah, question 40, please.